Hi, this is Science for Cycle 3, Week 13. We are done talking about the human body and human anatomy, and we are moving on to 6 weeks worth of chemistry experiments. So it'll be a little bit different. So as usual, you can read your Bible verse at the top of the page first and talk through how God created all of the matter in our universe to behave in certain ways. And He designed it perfectly so that it interacts with each other in the right ways to be able to sustain life here on Earth. And you can remind your class, as we'll continue to learn throughout the next 12 weeks, that none of this happened by accident, but God actually intentionally measured out the way that water works and all the other chemicals that we're going to talk about work. So we're specifically today going to talk about water. So we're going to talk about how liquid water molecules behave. So you can start by orienting your class to what a water molecule is. That if we get down to the tiniest parts of matter, if we were able to see them, which we're not even able to see them, we would see that water molecules are made up of 1 oxygen atom and 2 hydrogen atoms. And they are perfectly bonded together in a very specific way that allows water to behave so that it can sustain life on Earth. So you can have your class make a model water molecule. Here's what it'll look like. So I have a large marshmallow that's dyed red, and that will be your oxygen atom, because oxygen is a bigger atom than hydrogen. And then our 2 smaller molecules here are going to be our hydrogen atoms, and they are bonded together. So these toothpicks are representing our bonds so that they stay together in this form. That's why we call it H2O, is because there are 2 hydrogens and 1 oxygen atom. So you can have them make those, and they can eat the marshmallows if they want to. The red dye is just food coloring, so they're free to eat that if they want. And then you can talk a little bit about the different states of matter that water can be in. Challenge your class to maybe think of ways that they see water molecules in large groups in different states of matter, the way they maybe see steam coming when their mom is boiling water on the stove, or the way that they see ice and snow outside right now, or the way that they see liquid water when they turn on the faucet, or in the bathtub, or in lakes and rivers and things like that. But you can remind them that at its smallest state, water is just these little molecules that we can't even see with a microscope, but we can see them when they're in big groups. And you can talk about how those different states of matter behave. So you can even have your class act out the different states of matter that water can take. So in its solid form, you can have your class just kind of space themselves evenly apart, pretty tight together, but they're not going to move. Solid water or solid molecules are going to be tightly spaced, and they're not going to have a lot of energy, so they're not going to have a lot of movement. And then liquid water, our molecules are going to be a little bit farther apart, and they're going to kind of move around each other. They're always going to be moving. And then if you want to act out the gaseous state, gases have even more energy, so they move around a little bit faster, although you can have your class make sure to move carefully, but they're also going to fill up the space that they're in. So your class can be bouncing off the walls a little bit. They can be spread farther apart, because that's what gaseous molecules do. So again, just kind of orienting them to the different states of matter that molecules can be in, and we'll talk more about that over the coming weeks as we learn more about chemistry. So our question is about how liquid water molecules behave, and how specifically what's going to happen if we add other types of molecules to water. So your first experiment, you're going to have a clear pitcher of water, and you can ask your class to describe it. They might say it's clear, it's liquid, it's water, it looks clean, it's you could drink it. You can just have them describe everything that they can say about it. You're going to add a little bit of food coloring to it, mostly just to make the experiment more fun. And then don't stir it, but just have your class watch how the food coloring behaves in there, because what they can actually see is that these water molecules are moving around. So you can see the food coloring will spread out a little bit. And because the reason why it's doing that is that the water molecules and now the food coloring molecules are all moving around. They're not staying in one place. Just like we talked about, molecules in a liquid state are going to have some energy, and they're going to be moving around each other all the time. So you can kind of watch that happen for a little bit. It's pretty cool to watch the food coloring just move around. I'm going to swirl it up a little bit. And again, the blue food coloring is really just to make the experiment more interesting as you watch it. Okay, so now for your experiment, you're going to have a cup that's going to have masking tape along the side, and you're going to measure out a cup of liquid. I'm just going to do a half cup for the sake of conserving my isopropyl alcohol. So you're going to measure out a cupful of this water. And try not to spill it. And mark where 1 cup comes to on your masking tape here. So I'm going to mark about where 1 cup comes to, and then I'm going to do it again with a 2nd cup. Again, I'm just using a 1/2 cup. Okay, and I'm going to measure where 2 cups comes to. Okay, so I've got lines on here that show the gradations, 1 cup and 2 cups. And now I'm going to pour all my water back into my pitcher. Okay, so now, again, I'm going to measure out 1 cup of water, but this time I'm not going to add another cup of water to it. What I'm going to do is I'm actually going to add a cup of isopropyl alcohol and pour that into the cup. And I want you to ask your class what they think is going to happen, whether it's going to come to the same line here when we add the same amount of isopropyl alcohol, or whether it's going to be taller or shorter than the line, because we're going to have 2 cups that we're adding into here, but now instead of adding 2 cups of water, we're adding 1 cup of water and 1 cup of alcohol. And as we add it, you want to have your class stand back because it is pretty strong smelling. As we add it, you should see pretty apparently when you add it that it is less than the 2 cup line. And the reason for that is that the isopropyl alcohol and the isopropyl alcohol molecules actually move around and kind of fill in the spaces between the water molecules. And so it ends up being less volume in total than you would have if you had 2 cups of water. So you should be able to see that the 2 cups, that includes 1 cup of water and 1 cup of isopropyl alcohol, doesn't come all the way up to the 2 cup line that we made when we used 2 cups of water. So that's your first experiment. Again, you can talk through that. And then if you have some extra time, you can again have your class act out kind of what was going on in that experiment. You can have half of your class be the water molecules again, kind of moving in and out between each other, and then half your class act out the rubbing alcohol molecules that are going to be moving out in and out between the spaces in the water molecules. You can also do one more experiment. I'm going to go dump this really quickly. You can feel free to dump the rubbing alcohol down the sink. Just try to make sure you're in a well-ventilated area because it does kind of smell up the room a little bit. Okay, so for your second experiment, what you're going to do is actually take a cup, or I'm using a 1/2 cup again, of sugar and add it to your glass. So it should come up to the same line that you made here when you were doing your cup of water. And now ask your class, if we add a cup of water to that, what they think is going to happen. See what their hypothesis is. Is it going to reach the 2 cup line? Is it going to be more or less? And then you can add your cup of water. And this one will be really obvious. The water comes nowhere near that 2 cup line because that sugar is starting to dissolve in the liquid water. So what's happening here is that even though we had 1 cup of water, which was this much volume, and 1 cup of sugar, which is the same amount of volume, our liquid level is now less than the 2 cups because the water molecules are moving into the spaces between the sugar molecules and filling them up. You can stir it around a little bit with a spoon if you want to, but either way you'll see very apparently that the water does not come up to the same level that it would have if we had 2 cups of water. So again, this is just kind of our introduction to looking more into chemistry rather than biology. Yeah, that's it. Thanks.